Water is essential for all life on Earth, but with growing industrialization and urbanization, our water bodies are getting more polluted. Today, we dive into the world of screen wastewater equipment and how it helps keep our water clean. Hi everyone, welcome back to my water engineering channel. In today's video, we're exploring the fascinating world of screen wastewater equipment. This technology plays a crucial role in treating wastewater before it's released back into the environment. So, what exactly is screen wastewater equipment? In simple terms, it's a filtration system that removes large solids and debris from wastewater. Think of it as a giant sieve that catches everything from plastics to organic matter before the water undergoes further treatment. There are three broad categories in which you can classify wastewater treatment screens: coarse, fine, and micro. Within these categories are many different varieties of screening. The screens are classified based on the size of the screening openings, as well as other mechanical traits. First, we have the coarse screen, which removes large debris like sticks, rags, and plastic bottles. This protects downstream equipment and prepares the water for finer filtration. These coarse wastewater screens comprise numerous bars, wires, or rods that are placed parallelly. It is often referred to as a bar rack. The coarse screening method can also be classified into two types: hand-cleaned coarse screens and mechanically cleaned coarse screens. The hand-cleaned coarse screens are utilized in smaller wastewater treatment plants and facilities where the wastewater is hand-raked. This system is perfect for backup when it is a high flow time or more advanced, and the machine-operated screening method is not functional due to repair or maintenance. The mechanically cleaned coarse screens utilized in sewage treatment plants improve productivity, function, and overall efficiency while reducing the problems and complications the wastewater treatment process faces. Mechanically cleaned coarse screens can be divided further into these four main categories. Chain-driven screens. The chain-driven screens used in wastewater treatment plants can go front and back while raking upstream and downstream. There is an automatic chain in the system that cleans the stream while enhancing the performance of the overall wastewater treatment plant. Catenary screens. The catenary coarse screens front clean chain-driven screens employ simple and impressive internal mechanics to ensure the prevention of any further blockage due to large or heavy objects. Reciprocating rakes. Commonly referred to as climber screens, this wastewater treatment screening solution utilizes a singular rake rather than numerous ones, reducing their efficiency when facing heavy flow during the wastewater screening process in the plant. Continuous belt screen. This coarse screening operates with numerous rakes, making it one of the most high-tech. It enhances efficiency and increases functionality as this type of screening is a self-cleaning and continuous operation. This screen can also be used while dealing with fine or coarse solid loads. Next is the fine screen. With smaller openings, it captures particles such as sand and organic matter, reducing the load on subsequent treatment processes. These screens are created from perforated plates, wire cloth, or wedge wire. This part of the screening process is employed to remove finer solids that the coarse screens could not capture. There are three common fine screening types in wastewater treatment plants: drum screens, step screens, static wedge wire screens. Microscreening in wastewater treatment plants is when wastewater passes through the smallest screening. Microscreens are usually low-speed drum screens. The drums in the microscreening process have a lining of filtering fabrics with the smallest openings of approximately 10 to 35 micrometer. Wastewater enters the drum, and the retained solid waste is collected and disposed of. This diagram provides a comprehensive overview of how to select the appropriate screening equipment based on the quality of the incoming wastewater and the desired quality of the treated water. The selection process involves three key considerations. First, let's look at the quality of the influent, the incoming wastewater. We need to consider three factors here: the type and size of debris or solids present, the concentration of these solids, which could range from high to low, and finally, the flow rate and volume of the wastewater. These factors help determine the level of screening needed. Next, we focus on the desired quality of the effluent, the treated water. Here, we're concerned with the level of clarity and cleanliness required. specific treatment goals, such as the removal of certain contaminants or the reduction of suspended solids. Understanding these objectives guides us in choosing the right screening method. Finally, we select the screen type based on the influent and effluent requirements. Coarse screens. These are ideal for handling large debris in the early stages of treatment, primarily to protect downstream equipment. Fine screens. These are used when finer particles need to be removed, typically in more advanced stages to achieve higher effluent quality. Microscreens. These are necessary when very high effluent quality is required, ensuring even the smallest particles are filtered out. By carefully assessing the influent quality and defining clear effluent quality objectives, operators can select the most appropriate screening equipment, ensuring optimal performance and cost efficiency in the wastewater treatment process. Clean water is a precious resource, and screen wastewater equipment is one of the many tools we have to protect it. By investing in and maintaining these systems, we can ensure that future generations have access to safe, clean water. Thanks for watching. If you found this video informative, make sure to like, subscribe, and hit the notification bell for more content on environmental technology. See you in the next video.